start the session.
Shibina,
Okay.
Shibinachi.
Ah. A very good afternoon to one and all. Today's afternoon session is handling by eminent resource person Sir Ajinkya Lohangire on imbalanced data sets. Now I invite Ms. Ashida to introduce our resource person of the session.
Thank you, Shibina. I hope I am audible. Thank you, Shibina, and thank you each one of you who have gathered here for the third or final session of this fourth day of FDP on data sciences. In this session, we have an eminent resource person, Mr. Ajinkya Lohakar, and he is going to present about balanced dataset. Mr. Ajinkya is a certified ethical hacker and certified hacking forensic investigator too, and he have a rich experience in this field as a malware analyst. He is also a Python expert, blockchain expert, and data science expert as well. He is graduated from Pune University and he have achieved a lot of awards, such as in 2015 he have got Best Series Entrepreneur Award. In 2019 he was India Business Award winner, and he is a Vajra World Record holder, also Assam Book of World Record holder. Mr. Ajinkya is more well known for his significant work in the field of digital intelligence and security consultancy, since he have that much definitive experience in conducting this kind of training sessions on various topics related to computer security and all. We hope that this will be a fruitful, efficient session. So we are very much pleased to welcome you, sir. Let me welcome with all respect and humble Mr. Ajinkya Lohakar to start the session.
Okay.
Welcome you, sir.
Okay. Thank you and thanks for having me. My voice audible, right?
Yes, sir. Audible.
Okay, wait a minute. Screen visible?
Mm. Yes, sir. Now started sharing.
Okay, wait.
Visible.
And please ask your query after the session, okay? So first, good morning, so good afternoon, everybody. So from India, indeed, my name is Ajinkya. I'm CTO and founder of Ditto Security. So right now, everyone wants to be perfect, right? So why not our data set should be a perfect? Right now, everyone wants to be perfect. So what we'll be covering in this session, number one, the problems with imbalanced data set. Number two, what is balanced and imbalanced data set? Number three, the techniques to convert the imbalanced data set to the balanced data set. And number four, that is conclusion, demonstration, GitHub links, and the paperwork, right? Number one, that is problems with an imbalanced data set. Number two, what is balanced and imbalanced data set? Number three, techniques to convert the imbalanced data set to the balanced data set. And number four, that is the conclusion, then the paperwork and demonstration. So what is a balanced data set? Or let's say, if you're working in the leading tech company or Fortune 500 company or MNC company, and the company is giving you a task to train models on detecting a fraud, right? And here is the check. The fraud detection or the fraud transaction is relatively rare. The fraud detections or the fraud transaction relatively rare. So you just start to training your model and you get 95% accuracy. You just start to training your model and you get 95% accuracy. And you just feel good and put your model in front of your CEO and the founder, right? You just feel good and put your model in front of your CEO and the founder. And when they give input to your model is predicting that not fraud transaction every time, not fraud transactions every time. And this is really a problem because many machine learning algorithms are designed to maximize the overall accuracy. Many machine learning algorithms are designed to maximize the overall accuracy. Now, what happened means you get the 95% accuracy and your model is predicting the wrong information every time. So let's find it out why. So first, what is balanced and imbalanced data set? What are the balanced and imbalanced data set? So balanced data set. If in our data set, we have positive values, which are approximately same as negative values. I repeat once again, if in our data set, we have positive values, which are approximately same as negative values, then we can say that our data set in balance. If in our data set we have positive values which are approximately same as negative values, then we can say that our data set is in balance. And here you can see, here you can check. The blue color and red colors are the same, means the positive values and negative values which are approximately same. So that's why we can say that our data set is in balance. Now, what is imbalanced data set? What is imbalanced data set? If there is a huge difference between positive values and the negative values, then we can say our data set in imbalanced data set. What is positive? What is balanced data set? If in our data set positive values and the negative values which are approximately same, right? Then we can say that our data set is in balance. And there is a huge difference between the positive and the negative values, then you can say your data set, our data set is in imbalanced data set, right? And you can check the image here, that is imbalanced class distribution. My voice audible, right?
Yes, sir.
Okay, wait.
Yes, sir, it is audible.
Okay, cool. So it's all about the balance and imbalance. Now, how to manage, how to convert the imbalanced data set to the balanced data set? There are a lot of techniques available on the internet, right? You can use the random forest, you can use the logistic regressions, then the cross-site validation, right? And one more thing, you can use the different kind of techniques like upper sampling, up sampling, down sampling, right? So next one, problems with an imbalanced data set. Problems with an imbalanced data set. So, imbalanced data set, it's not a very big problem, because in real data sets, we have some sort of imbalance. We have some sort of degree of imbalance, right? And you can use the different kind of techniques, different kind of methods to balance the data set. For example, number one, that is use the right evaluation matrix. Techniques to convert the imbalanced data set to the balanced data set. Number one, use the right evaluation matrix, that is confusion matrix. So a confusion table showing correct prediction and type of incorrect prediction. Number two, precision. So precision indicates the higher number of false positive, and recall indicates the higher number of false negatives. Precision, the number of true positives divided by the positive prediction, and precision is also called as positive prediction value. And it is a measure of a classifier exactness. And low precision indicates a high number of false positive. Recall, low recall indicates a high number of false negative. So here you can check, recall the number of true positives divided by the number of positive values in the test data. And recall is also called as sensitivity or the true positive rate. And it is a measure of classifier completeness, and precision, it is a measure of classifier exactness. Measure of classifier completeness and classifier exactness, right? And low recall indicates a high number of false negative. Then next one, that is the F1 score. The weightage average of precision and recall. What is the F1 score? It's a weightage average of precision and recall. So first, understand the terminology. What is balanced? Mean positive and the negative values which are approximately same. What is the imbalanced data set? Means there is a huge difference between the positive and the negative values. Then how to convert the imbalanced data set to the balanced data set? There are a lot of methods you can use, right? Like upper sampling, down sampling, then the smooth or this smooth atomic methods. Okay, that is and please read the proper. Please read the understand the proper terminology. That is confusion matrix, then the precision, then the recalls, and the F1 score. I hope you all understood, right? Yes or no? Please post your answer in chat box. So
Yes, sir.
Okay. That's it. Then now first process, undersampling. Now what is undersampling? Keep it simple. Undersampling means what? Undersampling, on contrary to oversampling, aims to reduce the number of majority sample to balance the class distribution. Undersampling, on contrary over sampling, aims to reduce the number of majority sample to balance the class distribution. Just keep it simple. Means you just reduce the number of reduce the number of sample, right? And actually, obviously, this is not the best approach, because you discard most of the information. You discard the more of the information, like, right? So don't use the undersampling. I suggest you don't use the undersampling to handle the data set. So the undersampling, on the contrary to oversampling, aims to reduce the number of majority sample to balance the class distributions. And since it is removing observation from the original data set, it might discard useful information. Now, next one, oversampling. Now, what is oversampling? Oversampling is just like duplication. It's just a copy and paste kind of stuff. It's a duplication, copy and paste kind of stuff. Means you increase the number of sample, and then create your model. And here you just reduce the number of sample and create your model and test your model, right? So this is undersampling. And oversampling is what? This technique is used to modify the unequal data classes to create a balanced data set. This technique is used to modify the unequal data classes to create a balanced data set. And when the quantity of data is insufficient, the oversampling method tries to balance by incrementing. I repeat once again, by incrementing the size of prior sample. In the oversampling, you just increase the samples, you just increase the sample range, and then you just create your model and train your model, right? Oversampling, undersampling, oversampling. Now let's take practical, in a practical way. For example, undersampling majority class. So let's say you have 99,000 samples belonging to the red class, or you can say here blue class, red class, okay? And let's say green class contains the 1,000 samples, right? 99,000 belonging to the one class, let's say green class, and 1,000 samples belonging to the red class. Now, this is a classification problem, right? This is a classification problem, right? This is a fraud detection scenario. So now, how to undersample the problem, right? You can take 1,000 sample from green. You can take 1,000 sample from red, and then create your model. Means you just discard too much information here. 1,000 sample from 99,000, 1,000 sample from thousands, and create your model. Means you just discard most of the information. So I suggest you don't use the undersampling method. Means you just take 1,000 sample from the 99, 1,000 sample from second layers, and just create your model. It's all about the undersampling. I hope you all understand. And these 99,000 transactions means not a fraud transaction, and 1,000 samples are fraud transactions, right? And then create your model, test your model. So it's all about the undersampling. Then, and obviously this is not a best approach because you are throwing away too much data. You are discarding too much data, right? So this is all about the undersampling method. Reduce the number of sample and then create your model. Number 2, oversampling minority class by duplication. Oversampling minority class by duplications. Now, how to oversample it? Just do one thing. Take 1,000 transactions, 99 times, and then create your model. You just take 1,000 transactions 99 times. So we got 99,000 transactions, right? So we got, means it's just a copy and paste kind of stuff, copy and paste, okay? And then create your model. So it's all about the oversampling. Means you just increase the number of sample, right? So generate a new sample from the current sample by simply duplicating them. What is undersampling? Reduce the sample. What is oversampling? Increase the sample or duplicate the just copy and paste kind of stuff. Generate new sample from current sample by simply duplicating them. It's all about the oversampling. Now, there is another method in oversampling, that is oversampling minority class using SMOT. Oversampling minority class using this SMOT. So you can use the k nearest neighbor algorithms. And what is a SMOT? SMOT is a synthetic minority oversampling techniques, and then create your model with using this SMOT. And I just suggest you, instead of these 3 techniques, you please use the logistic regressions on the random forest. So otherwise use the ensemble technique. Because in the ensemble techniques we have the decision trees, right? So you just predict the proper results. The next one, that is ensemble technique. So if you have 3,000 samples from one class, 1,000 samples from another class, so take 1,000 samples from one class, take 1,000 samples from the another class, make the 3 batches, batch number 1, batch number 2, and batch number 3. Here we go. Batch number 1, batch number 2, batch number 3, and then take the majority votes. Like that is 1 plus 1 plus 1 equals to 1, 0 plus 0 plus 1 equals to 0. Take the majority votes and then create your model and then predict your results. It's all about the ensemble technique. I hope you all understood, right? Okay. So I repeat once again, wait a minute. Back to the slide. First, What is the undersampling? Undersampling, on contrary to oversampling, aims to reduce the number of majority samples to balance the class distribution. Since it is removing observation from the original data set, it might discard the useful information. So don't use the undersampling method, okay? Because you discarded too much information. Oversampling means what? Oversampling means just increase the number of samples, increase the minority class, and create the duplication things, means just copy and paste, increase the samples and create your model. Then in a practical way, take 1,000 sample from here, take 1,000 sample from here and make your model and train your such a kind of stuff, right? Then oversampling means duplication. Just take the 99,000 transaction 99 times and create your model. Means generate a new sample from current sample by simply duplicating them. It's all about the oversampling. Then next one, that is oversampling minority class using SMOT. So generate a k nearest neighbor algorithm here. And what is the SMOT? That is synthetic minority oversampling technique. And in Python, there is a model called Imbalanced. And please install the Imbalanced before applying anything, that is SMOT or the ensemble techniques or anything else. Okay, so please install the Imbalanced. Then ensemble techniques means what? If you have 3,000 samples from one class, 1,000 samples from the another, then make three branches, that is A, B, C, and take the majority votes. Okay, and then predict your result. So it's all about the ensemble upsampling, downsampling methods. Okay, and please don't use the downsampling. Okay, this method, undersampling methods. The next one, the advantage and disadvantages of oversampling. Advantage and disadvantages of the oversampling. Number one, advantages: unlike undersampling, this method leads to the no information loss. Advantage of oversampling: unlike undersampling, you lost too much data, right? Discard too much data. So this method leads to no information loss. Number two, outperform the undersampling. You can outperform the undersampling. Then the disadvantages of the oversampling, that is, it increases the likelihood of overfitting. And since it replicates the minority class event, Then next one, advantage and disadvantages of the undersampling. So the advantage of the undersampling: number one, it can help improve runtime and storage problem by reducing the number of training data samples when the training data set is huge. It can help improve runtime and storage problems by reducing the number of training data samples when the training data set is huge. And the disadvantages of the undersampling: you lost too much information. It can discard potentially useful information, which could be important for building rule classifier. Number two, the sample chosen by random sampling may be biased sample, and it will not be an accurate representation of the population, and thereby resulting in accurate results with the actual test data set. Okay, so it's all about the ensemble, then the oversampling, undersampling, and what is the balanced data, imbalanced data. You can use the different techniques to convert the imbalanced data set to the balanced data set, right? Now, do one thing here. Please download the data set from Kaggle. Just do one thing here. Please download the data set from the Kaggle first. Okay, that is credit card fraud detection. My voice audible, right? So just do one thing before applying the undersampling or the oversampling. Please download the data set. That is credit card fraud detection. The file is around 144 MB. Okay, wait a minute. So context is important, that credit card companies are able to recognize fraudulent credit card transactions so that customers are not charged for item that they did not purchase. And the database data set contains transaction may be credit card in September 2000. Okay, you just download the data set from here, that is Kaggle, and a lot of data sets available here. You can take any data sets and open in your Jupyter notebook. Okay, Jupyter notebook. So next thing. Now, import the basic required libraries, read the CSV. So before applying any different techniques, please create your model first, right? Like import the different libraries, import NumPy, then the pandas, then the PLT and the Seaborn. Then you can read your data set. First, import the data set. Okay, import the basic required libraries, read the CSV, import the libraries like initial necessary libraries, import NumPy as NP, import pandas, then the Seaborn or the PLT, then import your data set. Okay, The next thing, just keep it simple. Once you import the data set, just do next thing, like find out the count. Okay, find out the counts, value counts, means how many of zeros are there, how many of ones are there. And you can see here it has a huge number of records. It has a huge number of records. Wait a minute. Okay, check here. First, download the credit card, data set. Open your data set. Import pandas as a PD. They read the values from the credit card.csv data set name here. That is credit card.csv, right? And then you can check the shape. That is df.shape. Okay. Then you need to find out the independent features output value. And independent features output value is basically a class here. So inside the class you can write dot values counts. Okay. So you can check here how many of zeros are there, how many of ones are there, right? And you can check here it has huge number of records, And how to check the balanced and imbalanced data set? You can check here zeros are 2 lakhs. Wait a minute. Zeros are 2 lakhs 84,000 and ones are 492. So this is basically a classification problem and a detection problem. So you can check here it has a huge number of records. So first, import your data set, read the things, and your independent features output value is basically a class. So drop the column here, right? And then divided the features into the independent and dependent. Okay? I hope you all understand. Right? Okay. Now first import the libraries, then import the data set. Then next thing, target class exploration, get the count of the target or the visualize the target, right? That is data.target.value counts. You can check here how many of zeros are there, how many of ones are there. You can check the balanced or the imbalanced data set through the ratios. You can check the ratios, right? So it has a huge number of records, and this is actually fraud detection problem, classification problems. Okay, so you can use the logistic regression here. Okay, then next thing, then create your x and y. Before we start handling the data, create your x and y and check your shapes. Okay, create your x and y and take your shapes. First, import the libraries. Number 2, import the data set. Number 3, count the values. That is zeros are there, ones are there. Okay, then create your x and y here. That is x equals to data.drop. You drop the columns. That is class with axis 1. Okay, then y will only have the class value. Okay, then next thing, first step, that is undersampling. So use the near-miss method here. How to perform the undersampling? Please follow the necessary stuff like import the libraries, import the data set, and that is divide the features into the dependent and independent. Okay, now how to perform the undersampling? Just do one thing. Apply the near-miss method here. Okay, so and install the Imbalanced libraries here. Okay, from Imbalanced undersampling, import the near-miss, then create the instance of the near-miss, that is nm equal to the near-miss, and then use the dot fit and dot resample method here. Use the dot fit and dot resample method here. Okay, as simple as that. First, create your near-miss method, then create the instances of the near-miss, and then use the dot fit and dot resample method here. Okay. The next thing is that you can create the data frame. So let's have the count in some kind of data frames to see the differences in the glance. So you create the data frame here, so you can check the x shape, y shape, and target 0 and 1 values here. So technique, that is original data, x shape values are there, y shape values are there, then target zeros and the target 1. Okay, so first step, import the libraries, import the data set. Number 2, check the values, zeros and ones are there. Number 3, that is create your x and y's. Then drop the columns, that is class with the axis 1. Then take your shapes, then use the method, that is near-miss, create the instances of the near-miss, and use the dot fit and dot resample method here. Okay, then create your data frame, that is data tables pt.data frame, and then check the your x shape, y shape, target zeros and ones. Okay, then next thing, check the shape of x and y, and then you can use the own variables here. So print the whole statement shape of imbalanced data, display x shape, y shape, count of target, And you can check here that is original data and the data after near miss. You can print whole the statement here, count after the near miss, that is technique original data 595212, 595212. And now after the undersampling, you can check here, means you can take 433388, means 43,000, sorry, okay, you can take such amount from this, such amount from this, and create your model, that is target 1, target 2. Means take 1,000 transaction from one sample, 1,000 transaction from the another samples, and create your model. It's all about the undersampling method, as simple as that, right? Means take 1,000 sample from the red, 1,000 sample from the green, and create your model. It's all about the undersampling method. With using the near miss method, means you can create the instances, they use the dot fit and dot resample methods and create your model, right? Train your model. I hope you all understand. And if you have any queries, please post your queries in chat box so I can, right? My screen visible? Yes or no?
Yes, sir.
Okay.
Visible, yes.
Okay, wait a minute. Now, next method. Undersampling using the random undersampler. Undersampling using the random undersampler. So under random undersampler is fast and easy way to balance the data by randomly selecting the subset of data for the targeted classes. So you can import the random undersampler here. Then just use the dot fit or they create the resample on X and Y. Okay, import the libraries here. Report the random sampler here. Then random sampler. Then use the dot fit resample on X and Y. And that's it. And then check your shape here. That is values of zeros and ones, same as near miss. So first original data, X shape, Y shape, target 0, target 1, undersampling after the near miss. That it's around 4388. Undersampling random undersampler. So you get the same results, right? 21694, 21694. But you get the results early, like faster. Okay, with using the random undersampler. And in the oversampling, you can use the random oversampler. Okay, random oversampler. It's all about the oversample and random undersampler. So first import, then use the dot fit resample on X and Y, and just execute this. Okay. Then next one, that is oversampling. So one way to fight imbalanced data is to generate new samples in minority classes. One way to fight imbalanced data is to generate the new samples in the minority classes. And the most new strategy is to generate the new samples by randomly sampling with replacement of the currently available samples. That is random oversample. You can use the random oversampler here. That is then create the resamples, create on resamples on the X and Y, and then execute this, right? You can take the data here. And the values of zeros and ones, now the target class is now 573518 for both zeros and ones. Right, because you just increase the number of samples with using the oversampler. You just increase the number of sampler, right? Means you can take the 573518 from your 57358 and then create your model. You just increase the sample here. That is 1 lakh something. Okay, that is original data. You can check the original data, undersampling near miss, then the undersampling random undersampler, then the oversampling. Okay, so import the random oversampler, and in the undersampling import the random undersampler. Okay, that's it. Now set the float value here. You can use the parameter that is 0.5, that is sampling strategy parameter here, that is 0.5, that is 50%, right? So you can create the 50% duplications, means duplicate, right? You just copy and paste kind of stuff. Then next one, that is SMOT. Now, so basically SMOT, synthetic minority oversampling technique, consists of synthesizing element for the minority class based on those that already exist. It works randomly, picking a point from minority class and computing the k nearest neighbor for this point. The synthetic points are added between the chosen point and its neighbor. Okay, so you just import the SMOT, then use the parameter that is the sampling strategy minority, create the dot fit samples on X and Y, and then execute here. Okay. So the count of the target for 0 and 1s are equal here. That is 0 and 1. That is 573518, 573518. So check the different techniques here. That is original data, then the undersampling, oversampling, and SMOT. Then the next technique, that is SMOT-tomic. Okay. So these are the different techniques. So I repeat once again. So you just you understand the properly. Okay. So what is a undersampling? What is a balanced data set? Balanced data set means positive and the negative values approximately same. What is imbalanced data set? Means there is a huge difference between positive and the negative values. Now, different techniques check the confusion matrix, check the precision and the recalls and the F1 score. F1 score is it's around, and once you get the proper accuracy, it's not a great thing, right? Means it's not a good thing. So you just increase your F1 score. Okay, the weightage of average of the precision and the recalls. So the precision indicates the high number of false positive and the low recall indicates the high number of false negative. Then the undersampling, reduce the samples and create the models. Means take thousands from here, takes thousands from there and create your model. Now oversampling means what? They increase the samples and create your model. It's just a copy and paste kind of stuff. Now undersampling means undersampling majority class, take 1,000 from here and take 1,000 from there, then you can make your model, right? Then the oversampling, create the duplications, means take the 1,099 times and we got the 99,000s and generate your model. Then the oversampling minority class using smart, generate the synthetic examples using the k nearest neighbor algorithms and smart synthetic minority oversampling technique, right? Then ensemble methods, take 1,000 from 3,000s like and thousands, and then create the 3 batches and take the majority votes. It's all about the ensemble methods. Then the advantages and disadvantages of the oversampling, please use the oversampling instead of undersampling. Right? And here undersampling, you lost too much data, so please don't use the undersampling. Then the basic techniques like how to use the undersampling, then oversampling and the ensemble technique or the smart technique. So import the libraries, import the data set. Then next thing, check the values zeros and how many of zeros and how many of ones are there, right? And visualize the graphic representation. Then next thing, create your X and Y. And drop your columns, that is class with the axis 1, and then check your shapes. Then the undersampling using the near miss, create the near miss method, create the instances of the near miss, and use the dot fit and dot resample methods and just train your model. Then create data frame and check the shapes. Okay, now check the shape of X and Y, use the own variable, you can check your own, you can use your own variables. Now check the result here after the near miss. That is the original data. Undersampling methods. Undersampling methods, you just reduce the too much data here. You can check, you reduce too much data, like, right? 21694. 21694 and here, that is 5212. Means you lost too much data with using the undersampling. So don't use the undersampling. Then otherwise you can do the undersampling using the random undersampler. So the random undersampler is the fast, easy way to balance the data by randomly selecting a subnet of data for the target classes. Then number 2, undersample the majority classes by randomly picking samples with or without replacement. And from Imbalanced undersampling, you import the random undersampler here, use the different methods and just execute this. Okay. Now oversampling, one way to fight imbalanced dataset means increase the value, increase the increase the samples and just increase the just copy and paste and create your models or train your model. Use the different parameters, otherwise you can do with the cross validation or use the hyper parameter tuning methods. Okay. And one way to balance the data set, you can use the cross-site validation. The next one, that is SMOT. SMOT is the synthetic minority oversampling technique, consists of synthesizing element for the minority class based on those that already exist. It works randomly picking a point from the minority class and computing the k nearest neighbor for this point, and the synthetic points are added between the chosen points and its neighbor. So it's all about the different methods. Now just do one thing, please open your Jupyter notebook and please download the dataset, that is credit card fraud detection. Otherwise you can download the dataset, that is churn dataset, or cancer prediction dataset. Okay, first download the dataset, that it's around 144 MB. Then do next step. Okay, once you download it, please open in your working location.
Sir, go
Hello?
a little bit slowly. Little bit slow.
Okay, you want a little bit slow. Okay.
Yeah.
Okay, no issues. Wait a minute. Now, just do one thing here. You can download the dataset here, the credit card fraud detection, and then open your Jupyter. Okay. Then do first step, import your data set here, like down or import the necessary libraries here. That is import pandas as PD, then the df read csv, that is dataset name, that is credit.csv. Okay, and you can see here, you can check here, it has a huge number of records, right? Huge number of records. So type another query, that is df.shape. You can check the shape here, you can see the shape here. Then next thing is that I need to check my independent features output value, and the independent output features is basically a class here. Okay, so I just will drop the class with access 1, right? And inside the class you can write the values, that is dot values counts, right? So you can check how many of zeros are there, how many of ones are there, how many of zeros are there, how many of ones are there. Now, how to find out balanced and imbalanced data set? You can find out the balanced and imbalanced data set through the ratios, right? With using the ratios. So you can check zeros are 284,315, ones are 498. Huge difference between zeros and ones. So this is a classification problem, and this is a fraud detections. So 214,315 not fraud detections, and 492 are the fraud detections, right? Then next thing, you can divide the features into the dependent and independent features. Okay, you can divide the things into the dependent and independence, right? Then first, before applying any methods, you can use your own stuff, that is logistic regression or the random forest or the ensemble techniques to balance the data or the cross-site validation. Okay, use the different hyper-tuning parameters, right? So first, cross validation like k-fold and hyper parameter tuning. So first, import the logistic regression, then import the different libraries here, that is accuracy score. So you get the proper results, confusion matrix, classification report, accuracy score, confusion matrix, and classification report. Then you can create if you want to create the cross validations, please import the k-fold here. Then import the numpy and the grid search CV. Okay, import the numpy, grid search CV. Then just do one thing here, you just initialize the logarithmic classifier here, that is logistic regression. Then create your cross-site validation, and it's all about the that is hyperparameter tuning. It's all about the hyperparameter, right? And it takes the values of, that is 10 power of power of np dot arrange, and you can take the range between the -3 to +3. Then we'll have the another parameter, that is penalty. Penalty will have the values of L1 and L2. Okay, then do the cross validations on the k-fold and take the different parameters here, that is n splits, that is 5, and you can specify the state here, that is random state none and the shuffle false. Okay, number 1, import the data set. Number 2, check the shape. Number 3, inside the class, check your values like fraud or the not fraud detections, right? Like zeros are there, it has a huge number of records. Zeros are 284,315, ones are 492. Okay, and you can divide the things into the two features, that is dependent and independent features. Then import the different libraries here, that is accuracy score, confusion matrix, and classification report. So you get the proper results, proper predictions, and confusion matrix, right? Then wait a minute. Then here you can initialize. My voice audible, right?
Yes, sir.
Okay, wait. Now next thing, perform the cross-site validations and the hyperparameter tuning. Okay, so import these libraries, that is classification report. The next thing, initialize the logarithmic classifier here, that is logistic regressions. Then do the cross-site validations on the k-fold. Use the different parameters here and specify the state, that is random state is equal to none, and the shuffle value, you can use the default shuffle value, that is false. Okay, then next thing, then execute the things with using CLF equals to grid search CV. Use the parameter CV equals to CV, n jobs equals to -1, and here use the F1 micro parameter here. So F1 micro parameter, why you are using the F1 micro parameter? Because you get the proper accuracy. Okay, get the accuracy or the predictions with using the F1 micro. So you can check the F1 micro informations and the penalty information, penalty parameters. So penalty will have the values of L1 and L2, and the F1 micro used for check the accuracy. Okay, then before this you can create the X and Y here. Okay, so import the train test split here. So create x train, x test, y train, y train, y test equals to train test split. Okay, create train test split here. Then execute this and check the prediction then. Okay, with using the cross-site validation, you can check the prediction here. So we get almost like decent. Okay, we get the decent accuracy here. Okay, decent accuracy here with using the cross-site validation. And you need to change, you need to increase the F1 score here. That is average weightage average of precision and recalls. Okay, that is micro average, weightage average. So you can check here, that is a false negative, false positive, and the false negatives. You need to increase the values here, that is 104, with using different kind of methods, that is undersampling, oversampling, and the smooth or the spot comic. Okay, then so it's a cross validation and a hyperparameter tuning. So please use the cross validation, hyperparameter tuning, or the logistic regressions. Okay, so you can balance this stuff, balance the imbalanced data, one way to balance the data. Okay, then next thing, now undersampling. Now how to perform the undersampling? Just do one thing here. From collection, import the counter. Please import the counter. Then the counter y train. You can find out with using the counter. You can find out the values of zeros and ones. So one are the fraud detections, like fraud values, and not fraud, that is are not fraud. Okay. Then import the counter. Use the Imbalanced. Okay. Under the Imbalanced or the near miss method here, create the instances of the near miss. It's around 0.8. So 0.8 means 80%. You reduce the 18% samples. You reduce the 18% samples, right? It's all about the undersampling methods. And then create your X train, Y train here, and use the feed sample or the feed resample method, and then print the statement here. That is, print the number of classes before the feed and after the feed, and then execute this. Execute this. So the number of classes before feed counter, it's around 1,99,000, and ones are around 247. Okay, and after the feed, you can check here, that is 433 and 347. 433 and 347. It means you just reduce too much number here. Okay, with using the undersampling. With using undersampling means in the undersampling, just use the near miss method, then create the instances of that near miss, then create use the dot feed dot resample methods, and create your predictions or check your predictions there. Okay, so I suggest you don't use the undersampling method. Okay, then next thing, you can initialize the random forest classifier here. Random forest classifier, then execute the random forest classifier, and then check the predictions once again. So here you can check the 135, means your values just increase, and your accuracy is around 0.75, right? So you need to increase the F1 score. You need to increase the F1 score. That is weightage average of what? That is the precision and recalls, right? So it's all about the undersampling. Number one, I repeat once again, how to perform the undersampling. You can import the counters, means you can check the values of zeros and ones, like fraud and not fraud detections, right? Then import the counters to check the values. Then import the methods, that is near miss, and create the instances of near miss, reduce the values 80% or the 75%, right? And take 1,000 from there, and take 1,000 from the one sample, take 1,000 from the second samples, and create your model. The second thing is initialize your random classifier here, random forest classifier here, and check your predictions value. Okay, so it's all about the undersampling. Now next thing, that is oversampling. Now what is oversampling? Oversampling means you just increase the number of samples, increase the number of samples, right? So just import here, that is random oversampler. Okay, so oversampler equals to the random oversampler is 0.75. So just increase the value of 0.75, right? 75%. So then repeat the statement, that is the number of classes before the feed and the number of classes after the feed. Number of classes before the feed and number of classes after the feed. So you can check the result here. Execute this. The number of classes before the feed.
Sir, it's not visible. Is it possible to zoom or maximize that code?
Okay, code not visible, sir.
Not visible. Very small font.
Okay, wait a minute. My voice audible, no, sir? Screen
Voice
visible, right?
No problem. Voice, no problem.
Okay, wait a minute.
Code is not visible. Possible.
Now?
Yeah. Now okay, good.
Now visible, no?
Yes, sir. Yes, visible.
Okay, now just do one thing. How to perform the oversampling? Just use the different necessary libraries, import the different necessary libraries and everything, right? Import your data set and everything. Then how to perform the undersampling? Just do one thing. Import the counter. Now, why we are using the counter? Because you can find out the values of zeros and ones, right? Zeros are, it's around 1,99,000. Ones are, it's around 347, right? Now, just do one thing. Import the counter, then use the create near miss method here, and then create the instances of the near miss, increase or reduce the 0.8, that is 80%, reduce the 80% sample. Means what is the undersampling? In the undersampling, you reduce the sample, right? And then print the statement here, that is number of the classes before the feed, number of the classes after the feed, and format counter ytrain underscore ns, that is near miss, okay? That is instances of the near miss, and check here, that is the number of classes before the feed, it's around 2 lakhs and ones are 347, and then the number of classes after the feed counter, it's around 433. Means you lost too much information here, you lost too much information, right? You lost too much information in the undersampling. So I suggest you don't use the undersampling, right? The next thing, next one, use the random, you just initialize the random forest here, then classifier equals to the random forest, classifier just fit on the X train and the Y train, then execute your random forest classifier, and then predict your things. It's all about the prediction. Wait a minute. Random forest, and you can check your accuracy here. Then check your precision, recall, F1 score. You need to increase your F1 score. That is the weightage average of what precision and the recalls. Then second thing is oversampling. In the oversampling, you increase the samples, right? You increase the values of samples. So you increase the values with 0.75. Okay, oversampling equals to the random sampler. Then create the feed on X train and Y train. Then you print the statement, that is the number of classes before the feed and the number of classes after the feed. The number of classes before the feed and the number of classes after the feed. So you can check here the number of classes before the feed, that is 2 lakhs and 347s, and after the feed you just increased by 70% or the 75%, and it's around 2 lakhs, and ones are around it's around sorry, okay, 19 or 20 lakhs something. Okay, so you just increase the samples here with using the oversampling. Then you can initialize here, that is a random forest classifier. Wait a minute. A random forest classifier, just do a fitting on the X train and Y train, execute this random forest classifier. You check the accuracy here, that is 0.99, and exactly here the F1 score is increased, means 0.95, 0.81, and then the previous one, that is in undersampling. Okay, wait a minute, that is 0.95 or random for it. It's around 0.95, 0.79, and in the oversampling, it's around 0.95, 0.81. You just increase your recall, okay, or this F1 score. Then next one, that is smooth technique, or you can directly use this smooth tomic technique, okay. Or next one, that is ensemble techniques. So from ensembles, you need to initialize or import the AZ ensemble classifier here, and execute the AZ ensemble classifier. Then predict your things. You can check your privacy, very bad, accuracy, very bad accuracy here. Sorry, very bad precision or the F1 score, that is 0.08. So don't use the ensemble technique, okay. So better option, please do the logistic regression, or random forest, best option. Okay, so I repeat once again. So okay, so first import your data set, right? Import your data set, that is import pandas as pt, credit card csv, the name of the data set. Then shape here, you can find out the shape. Then you can I need to find out the values of dependent independent variable output value. It's basically a class. So inside the class you can type the values, that is values underscore count. So you can check the values of zeros and ones. So this is a classification problems or the fraud detection scenario. So 2,84,315 are the fraud, not fraud detections, and 492 are the fraud detections. Okay. Then divide the features into the independent and dependent. Then import the different libraries here before applying any methods. You can use the cross-site validations on the k-fold and the hyperparameter tuning. Use the different hyperparameter tuning, right? So this is the logistic regressions. Import the different libraries or the parameters, that is accuracy score or confusion matrix. So you need the proper accuracy. Okay, then here you initialize the logarithmic classifier, that is logistic regressions. Then create the cross-site validations on the k-fold and use the different parameters here, that is n split default parameter equals to 5. Then specify the random state none, then shuffle defaults to the false. Okay, then the penalty will have the values of L1 and L2. Then execute this, that is CLF equals to greet search CV. Then they use the parameter CV equals to CV basic parameters. Then F1's micro is basically a parameter used for accuracy or the results or the predictions. Then the CLF dot fit, just do the fit on the X train and Y train and execute this. Right? So then execute this and you get the 99% accuracy here, and the precision is around 0.69. Recall it's around 0.72, and F1 score it's around 0.70. Okay, so you need to increase the F1 score, okay, with using the different techniques, that is undersampling. Now, how to perform the undersampling? You can import the counters. So with using the counters, you can find out the values of zeros and zeros and ones, right? Then import the counter here, import the counter, then import the near miss method, then create the instances of the near miss and reduce the samples by 80%, that is 0.8, right? Then the X train, create the X train Y trains fit sample, then print the statement, that is the number of the classes before fit, the number of the classes after the fit. Okay, it's around the number of the classes before fit, it's around 2 lakhs and 347, and after the fit it's around 433 and 347. Then use the random forest, initialize the random forest classifier, then execute the random forest classifier. Okay, then perform the oversampling. Now, how to perform the oversampling? You can use the random oversampler, okay, and in the undersampling you can use the random undersampler. Okay, so the oversampling equals to the random oversample. You just increase by 70%, right? You just increase the samples by 70%. Just create the X train, Y train. Okay, just create the instances and print the number of the classes before the feed and the number of the classes after the feed. So here you can check here the values of zeros and the ones increased by 70%, right? So in the oversampling, you just increase the sample, and in the undersampling, you just reduce the sample. Just keep it simple. Okay. Then the next thing, that is a random forest classifier. Initialize and execute this and check the accuracy here. That is 0.95, 0.81, 0.88. And in the first, with using the cross-site validation, you can check here, that is 0.95, 0.79, 0.95 and 0.79. Wait, 0.95 and 0.79. Here you can check your recall increased, right? Your F1 score increased, that is 0.88. Okay, so please use the oversampling method. The next one, that is SMOT technique, or the SMOTech techniques, and next one, that is assemble technique. So initialize the assemble here, assemble classifier, then execute this and check your results, check your predictions. And very bad accuracy, very bad F1 score. Okay, so don't use the ensemble technique. I suggest you please use the base technique, that is oversampling instead of undersampling, or the SMOT technique. Okay. Sir, can you share? Okay, I will share with you. Okay, and if you want more files like how to perform the balance and imbalance dataset, I will share the files with you, dataset plus files. Okay, Python file and everything. Okay, I hope you all understood, right? How to work with the balance and imbalance dataset, how to perform the different techniques. My voice audible? Can you hear me?
Yes, sir. Yes, sir.
Okay, great. So first, understand the terminology. Okay, first understand the terminology, then perform the different tasks. Import the libraries. First, import the libraries. Check here. Import the libraries. Second thing, import the data set. Then third, check the values of zeros and ones. That is, zeros are 573518 and ones are 21694, right? Then create your X and Y's, check your shapes. Then next thing is that perform the undersampling with using the near miss methods. Okay, so create your near miss and create your instance of the near miss, and then create the fit sample methods or the dot fit methods on the X and Y, right? And then you can check the shape here. That is, let's say I have the counts in some kind of data frames to see the difference in the glance. Okay, that is technique original data. X shape it's around 6 lakh, Y shape it's around 6 to 7 lakh or something, 6 ER or something. Okay, or 59 lakhs. Target it's around 21694. Means you just reduce the too much data, right? You reduce the too much data in the undersampling. Undersampling, you check the result here, that is X shape, Y shape, and target. You reduce too much data in the undersampling counter after the near miss. Then you can use the another technique, that is undersampling using the random undersampler. So initialize the random undersampler here and just do the dot fit or the dot resample methods and execute the model. Now you can check the original data, undersampling data after the miss, and undersampling random undersampler. Okay. Then the oversampling means just increase the data or increase the samples. So random oversampler here, X underscore OS 5 underscore, okay. And if you want to perform, you can perform here also, okay, in the Kaggle notebook. Okay, so please download the data set and import the data set and work and perform the balanced and imbalanced data set task, okay. So you can initialize your random oversampler here and then create your dot fit methods, resample methods, create on X and Y, and check your techniques or check your count here. In the original data, it's around 59 lakhs, or it's around 5,95,000. Then 5,95,000 in the undersampling, you lost too much data. It's around 43,000 only. Okay, so don't use the undersampling. In the undersampling random forest, same data you will get, right? In the oversampling auto. Okay. Then here in the random oversampler, you just type the parameter that is 0.5%, and then wait. Next one, that is smart technique. In the smart technique, you just and the smart technique. Okay, so these are the different methods. Okay, you can convert the imbalanced data set to the balanced data set, like undersampling, oversampling, or you can use the logistic regression, random forest. Okay. So I repeat once again, please check here. First thing, download the dataset from the Kaggle, okay? Then open your dataset or import your dataset here with using import pandas as PD, and the name of the dataset, that is credit card.csv, okay? And it has a huge number of records, right? Dataset, it has a huge number of records, and you need to check the values of zeros and zeros and ones, because this is a classification problem. And what scenario? That is the detection scenario, fraud detection scenarios, right? Means you get the 95% accuracy, you feel good, and you just put your model in front of your CEO and the founder, and when they give the input to your model is predicting the not fraud transactions every time, right? So you need to balance the data. So first, DF shape, check the DF shape here. Then next thing, you need to add the values and count. So you can check the values of zeros and ones, that is 284,315, right? Then divided the things into the features, that is independent and dependent features, right? Then instead of the random forest, you can import the logistic regression here, right? So from sklearn.linear model, import the logistic regressions. Use the different libraries, import the different libraries for gauge the proper result, that is accuracy score, then the confusion matrix, and the classification reports, right? Then for the cross validations, you just import the k-fold, that is numpy or the np, and then import the grid search cv, right? Then next thing, wait, okay, here initialize the logarithmic classifier, that is the logistic regression, okay? Then grid equals to c, that is hyperparameter, right? So we'll have the values between -2 to -3, okay? Then another parameter, that is a penalty. Penalty is used for the completeness or the correctness. So we'll have the values of L1 and L2s. Then you can do the cross validation on the k-folds. Check the parameter, that is default parameters, split equals to 5. Specify the states, that is the random states equal to none, and shuffle equals to the false, right? Then execute this, that is CLF equals to grid search CV. Then in the log class, the parameter grid CV equals to CV. Then here you can use the F1 parameter, okay, F1 micro parameters. So F1 micro is used for the scoring. It's a scoring parameter. Okay. Then next one, clf.fit, execute on the X train and Y train, execute this. And before this, you can create your X train and Y train. Okay. That is X train test and split, train test split. Okay. And then execute this. Then Y prediction on the X test. Okay. And then print the statement, that is print confusion matrix, print accuracy score, print classification report here. That is Y test and Y prediction. So you can change the false positive, false negatives. Then the accuracy here, precision indicates the values of what? The false positives, and recall indicates the values of false negatives, right? And F1 score, it's the weightage average of the precision and the recalls, right? Now, how to increase the F1 score? Use the different techniques, right? In how to balance the data set, use the different techniques, right? Now, then, okay, that's it. Then here we go. You can check. You can perform the undersampling here. Now, what is undersampling? Undersampling means what? In the undersampling, you reduce too much data. You just decrease too much data. You lost too much data. You just discard too much data, right? So from collection import counter. So why we are using counter here? Because counter specify the values of zeros and ones, right? So counter, you can check the values of zeros and values of one. That is fraud transactions and not fraud transactions. Then next thing, from collection import the counter from undersampling, import the near miss, create the near miss method, and then create the instances of the near miss. It's with the by 0.8, that is 80%, means just reduce the sample 80% and then create an X train, Y train, just do the fit and resample it. Okay. And then print the statement here, that is print the number of classes before fit, counter Y train, and print the number of classes after the feed. So you can check here, that is it's around 2 lakhs and 347, means you reduce after the feed, you reduce too much data here, right? Discard too much information. So don't use the undersampling, right? Then here you just initialize the random forest classifier, then check your predictions. The next step, that is oversampling. In the oversampling, you just increase the values, increase the samples, right? So first increase the samples by 70 or the 75%, right? So you can check here, or then print the statement, just do the fit methods or the resample it, right? And the number of the classes before the fit, it's around 2 lakhs 347, and now it just increased, 347 increased, right? After the fit. So it's around the oversampling. In the oversampling, you just increase the samples, right? Then initialize the random forest here and execute this and check your accuracy here, false positive, false negative, precision score, recall, and F1 score here. Then the accuracy, micro average, and the weighted average. Okay. Then next thing, that is smart tomic. In the smart tomic, please install the import the library, that is Imbalanced. Okay. Sorry, from Imbalanced combine imports smart tomic here, and then oversampler equals smart tomic 0.75, and print the statement here. You just increase too much information. So that is 198.395 and 148640. Then initialize your random forest and execute this. Check the accuracy, check the precision score, recall, and F1 score. Okay. Last method, that is ensemble technique. Import the easy ensemble classifier, initialize here. Okay. And then execute this. You can check here, that is a precision, it's around 0.4%. Like bad precision, bad recall, F1 score. So don't use the ensemble technique, right? I hope you all understand, right? Understood, right? Yes or no?
Sir, one doubt is there, sir.
Yes, sir. Please proceed.
What is this hyperparameter tuning? Sir, can you hear me?
Yes, audible, Manas.
Okay. What is this hyperparameter tuning? That is my question.
Hello. Hello.
Yes, sir. Yes, sir.
Manas, ask one more time.
Sir,
Hello.
my question is, what is this hyperparameter tuning?
Basically, hyperparameter, is a model argument whose values is set before the learning process begins. And the key to machine learning algorithm is hyperparameter tuning, right? Voice audible or not?
Yes, sir. Yes, sir. Yes, sir. It's
So
audible.
basically, the hyperparameter is a model argument whose value is set before the learning process begins. Okay.
Okay.
Sir, hello.
Hello. Hello.
Sir, in that hyperparameter tuning, you have mentioned some penalty and F1 macro, some parameter values you have mentioned. Any other alternative values are there, or how
You
we
can use the different default values. Okay. You can use the different parameters, not only the hyperparameter. In the hyperparameter, there are a lot of parameters you can use it. Okay. I just only mentioned a few of them.
Okay, sir. Thank you.
Okay. Anyway,
Okay, sir.
Wait a minute. Wait a minute. Okay. Now, if you have any query, please post your queries in first. Okay. And please download the data set and opening your Jupyter, and please balance the convert use the different techniques to convert the balanced data imbalanced data set to the balanced data set. Okay. And instead of this, please use the logistic regressions on the random forest instead of such a kind of techniques. Best option, or the cross-site validations and the hyper tuning. Okay. I hope you all understood about the what is the balanced, imbalanced data set. And if you want the files or data set, please let me know in chat section. Okay. Otherwise, I will share directly the GitHub links. Okay. Or please share your mail IDs with me.
Sir, can I ask one more question?
Go ahead.
Sir, in undersampling, you are not recommending undersampling because some drawback is the lack of information loss.
I mentioned you lost too much information. You lost, you discarded too much
in
information.
oversampling also some overfitting problem is there. So, which is the proper suitable method that we can defend?
Don't use such a kind of techniques. It depends on you. You can use the oversampling, otherwise logistic regression, random forest. Best option the cross-site validation. You do the cross-site validation, right?
Okay. Okay, thank you, sir.
Okay, here you can check the advantages and disadvantages of the oversampling. Okay, so the advantages of the oversampling, that is, unlike undersampling, this method leads to no information loss. And number two, outperform undersampling. And the disadvantages of the oversampling, it increases the likelihood of overfitting since it replicates the minority class events. Okay, and next one, that is undersampling. The undersampling disadvantages, it can discard potentially useful information which could be important for building rule classifier. And number two, the sample chosen by a random undersampling may be a bias sample and it will not be an accurate representation of the population and resulting in the inaccurate results with the actual test data set. And the advantages of the undersampling, it can help improve runtime and storage problem by reducing the number of training data samples when the training data set is huge. Okay. It's all about the imbalanced and balanced data set. Okay, use the different techniques and just balance the data set. Use the different methods or the parameters Then the libraries, import the different libraries, initialize the classifiers and everything. So you just manage all the things, okay? Here you can check in the undersampling, the original data is around 5 lakh, right? 5 or 6, okay, 5 lakh something. And after the undersampling, you just lost too much data, right? Original data it's around 5 to 6 lakh. And after the undersampling, after the near miss, we got like 43,000. Only 43,000 means you lost too much information in the undersampling. And okay, oversampling. So in the oversampling, you just increase the samples, right? Increase the sample. So the original data it's around 6 lakh. After the undersampling near miss, it's around 43,000. Then the random undersampling is around 43,000, and after the oversampling, it's around 1 lakh. Oh, sorry, 1 crore something, 1 CR something. Okay, so you just increase too much data with using the oversampling. So the oversampling out of the target class is now 5735184 for both 0 and 1. So the basic thing, use the different parameter, different libraries, and just manage the data sets. Okay. So if you have any queries, please post your queries.
Participants, please ask your queries.
Participants, you can ask if you have any doubts. Sir, is there any case study for this? How to handle imbalanced data sets?
Sir, I will share with you white papers and case studies. I will share with you. Okay, if you want case studies and other kind of stuff or the material, and if any participant wants material, please post your email IDs. Otherwise, I will share with you, sir. Okay, you can share with the participants.
They will ask later. I will share to them.
Okay, okay, okay. So I will share with you the white papers, case studies, and some sources. Okay.
Okay, okay.
Okay, sir. So is there any query? Please post your queries in chat box. Otherwise, post your queries on my. Wait a minute.
Sir, write your mail ID in chat box.
Okay, sir. Wait a minute. Okay, so you just post your queries on my LinkedIn account or second email ID, my own email ID here, that is socialspectraz@gmail.com. Okay. Now screen visible, okay, right?
Yes, yes, visible.
Okay, so you can post your queries, and if you learn more and more things about the data science, like if you want to do the R&D kind of stuff, please post here, okay, right?
Participants, if there is no doubts, no questions, we will wind up.
Yes, sir.
Okay, sir. Now I invite
Proceed,
Manas Rahman. Sir, can I continue? Kumar,
Yeah,
sir?
continue.
Okay.
Continue.
Now I invite Manas Rahman to deliver the vote of thanks to our resource person.
Thank you, Shibna. Thank you, Ajanya Lohare, sir. It's a very wonderful class, and you have handled that, how we can handle that balance and imbalanced data in an appropriate way. And thank you for spending this much of time with us, sir. Actually, you have spending your valuable time with us. So thank you, sir. And thank you for the participants for their active participation. And also, I express my heartily thanks to Kumar, sir, for conducting and calling this Lohare, sir, for this event. And I think it will be a great opportunity for all of us to hear from you. And in the coming future also, we will expect your cooperation, sir.
Okay, sure.
So, okay, sir. That's all, sir. Thank you. Thank you, everyone.
Thank you, sir. Thank you.
Thank you, sir. Thank you, Ajanikya, sir. Thank you very much for spending your valuable time. On behalf of Department of Computer Science and Central University of Kerala, thank you very much for
Thank you, sir. Thank you.
a wonderful talk.
Thank you.
Thank you, sir. Thank you. So, participants, do you have any queries? Whatever the PPTs shared by the resource persons, I am sharing to you. Still now, I received only keynote address PPTs that I shared, and all the sessions, videos, Google Drive links also shared to you.
Yes, sir. Yes, sir.
Okay.
Sir, then we can continue tomorrow. 10 a.m. now.
Same time, 10 o'clock only. Tomorrow, 10 o'clock only. Tomorrow, 2 sessions. After lunch, yoga is there, 2:30 to 4. After that, valedictory is there. Exam starts by between 11:30 to 12 o'clock. We have to submit your answers before 4 o'clock. Okay, after 4 o'clock, valedictory session. I hope that's clear.
Yes, sir. Yes, sir.
It's clear. Okay. So, if any doubts are there, you can ask, or else we can wind up the today's session. We have successfully completed 4 days. Thank you all for your cooperation. Thank you. Okay, Manas, we'll stop today.
Okay, sir. Thank you, sir.
Thank you all the guys.
Thank you, sir. Thank you, sir.
Thank you, sir.